the branch of chemistry which deals with the chemical changes by applying electrical energy is called as electrochemistry. So to carry out some chemical reactions, we need electricity. And by carrying some chemical reactions, electrical energy is produced. So the branch which is related to such type of reactions is called as electrochemistry. కొన్ని రసాయన చర్యలు జరగడానికి విద్యుత్ శక్తి అవసరం అవుతుంది. అదేవిధంగా కొన్ని రసాయన చర్యలు జరిగినప్పుడు మనకు విద్యుత్తు ఉద్భవిస్తుంది. ఈ రకమైన చర్యల గురించి తెలియజేయు భౌతిక రసాయన శాస్త్ర విభాగాన్ని విద్యుత్ రసాయన శాస్త్రం అని అంటారు. So there are so many applications with this electrochemistry. So for example, astronauts are traveling in the space, they are doing their research. So they need energy and water to reach there. So for that we are using fuel cells. So that is related to our electrochemistry. That's why it is an important topic in physical chemistry, and definitely we can get a question from this topic. So here, what is the importance of electrochemistry? It relates with the production of metals like sodium, magnesium, calcium, etc. సోడియం, మెగ్నీషియం, కాల్షియం వంటి లోహ సంగ్రహంలో దీన్ని ఉపయోగిస్తారు. తర్వాత ఎలక్ట్రో ప్లేటింగ్ లోను, ఇన్ ద ప్యూరిఫికేషన్ ఆఫ్ మెటల్స్ లోహాలను శుద్ధిపరచడంలో, తర్వాత బ్యాటరీస్ అండ్ సెల్స్ యూజ్డ్ ఇన్ వేరియస్ ఇన్స్ట్రుమెంట్స్. సో దీస్ ఆర్ ది ఇంపార్టెంట్ applications which are going to be studied by this chapter. So if you see this one, so what are conductors? The substances which allow electric current to pass through them are called as electric conductors. Conductors are electric conductors. Generally, if you see the conductivity of these conductors will be the order of 10 to the power of 4 to 10 to the power of 7 ohm inverse meter inverse. Here, by increasing the temperature, the conductivity decreases. So therefore, some other substances are there, they are semiconductors. For that, the conductivity of semiconductors increases by increasing temperature. And the range of semiconductors is like this. This is 10 to the power of minus 6 to 10 to the power of 4 ohm inverse meter inverse. And if you take or consider insulators, these are the substances which do not allow the current to pass through them. They don't have any conductivity. So their range will be like this. Again, the conductors are two types. Electrolytes or electrolytic conductors. In this one, what happens? The electricity is passed through their fused state or aqueous solutions. For example, aqueous solutions of acids, say HCl, H2SO4, and so on. And bases like sodium hydroxide, KOH, etc. And some other type of conductors are there. They are electronic conductors. So in this one, only the current is passed through the passage of electrons only. Such conductors are called as electronic conductors. For example, if you see this one, the aluminum wire, copper wire, etc. will be used. Sodium metal, generally it has some less conductivity. And if you see, generally in our electric wires, generally we observe we have copper wires and aluminum wires in them. What is electrode potential? When an electrode is in contact with the solution of its ions, in a half cell, it has a tendency to lose or gain electrons. So, ఏదైనా ఒక ఎలక్ట్రోడ్ ని దాని అయాన్లు గల ద్రావణంలో ఉంచినట్లయితే, సో ఇట్ మే లూజ్ ఎలక్ట్రాన్స్ ఆర్ ఇట్ మే గెయిన్ ఎలక్ట్రాన్స్. అది ఎలక్ట్రాన్ కోల్పోవచ్చు లేదా గ్రహించవచ్చు. ఈ ఎలక్ట్రాన్ కోల్పోయే లేదా గ్రహించే స్వభావాన్ని మనం ఎలక్ట్రోడ్ పొటెన్షియల్ అని అంటాం. సో ఇఫ్ ఇట్ లూజెస్ ఎలక్ట్రాన్స్, that is called as oxidation potential. It is losing of electrons. And reduction potential, what is that? By gaining of electrons is called as reduction potential. సో ఎలక్ట్రాన్ కోల్పోయే స్వభావాన్ని మనం ఆక్సిడేషన్ పొటెన్షియల్ చెప్పవచ్చు. ఎలక్ట్రాన్ గ్రహించే స్వభావాన్ని రిడక్షన్ పొటెన్షియల్. సో ఇఫ్ యు సీ ఇన్ అవర్ టెక్స్ట్ బుక్, the electrochemical series is there. Simply they have given electrode potentials. So if you say that electrode potentials is nothing but they are equal to reduction potentials. Always the oxidation potential and reduction potential of an electrode is equal and which has opposite direction. Here, electrochemical cells are there, and that is not in our syllabus. And we have standard hydrogen electrode. Standard hydrogen electrode. Very simple. By taking 1.12 m HCl solution, and here you keep one platinum wire in your test tube, and here you send hydrogen gas into this one. Through this one arrangement will be there. Here, if you send hydrogen gas at 1 atmosphere, and this arrangement, this will be worked as standard hydrogen electrode. So pramana hydrogen electrode 1.12 m గాఢత గల HCl సొల్యూషన్ తీసుకుని ఒక ప్లాటినం వైర్ ని అరేంజ్మెంట్ చేసేసి 1 atmosphere ప్రెషర్ తో మనం హైడ్రోజన్ పంపించినట్లయితే అది ప్రమాణ హైడ్రోజన్ పనిచేస్తుంది. సో what is the role of standard hydrogen electrode? It is a reference electrode. To detect the EMF of an electrode directly is not possible. So therefore, this can be taken as standard, and in which the EMF of hydrogen electrode is always, this can be taken as 0. So by this, this is a standard hydrogen electrode. And better than this one, దీనికంటే ఇంకా మంచిగా కూడా మనం ఏం వాడచ్చు అంటే calomel electrode కూడా వాడచ్చు. In the calomel electrode, here what we use? Mercury. is used, and this mercury is in contact with what? HgCl2. This is called as calomel. And this mercury chloride, this is HgCl2, will be dipped and formed as what? A paste. And nowadays the calomel electrode is advanced reference electrode. It consists of mercury, which is in contact with the HgCl2 paste in KCl solution. Where? In KCl solution. Next, electromotive force. What is this EMF? The difference between the electrode potentials of two half cells, which can cause flow of current from an electrode at higher potential to the other electrode at lower potential. This is called as what? Electromotive force. అధిక ఎలక్ట్రోడ్ పొటెన్షియల్ గల ఎలక్ట్రోడ్ నుండి తక్కువ ఎలక్ట్రోడ్ పొటెన్షియల్ గల ఎలక్ట్రోడ్ నకు విద్యుత్ ప్రవహించినప్పుడు వాటి ఎలక్ట్రోడ్ పొటెన్షియల్ మధ్య భేదాన్ని ఎలక్ట్రోమోటివ్ ఫోర్స్, విద్యుత్ చాలక బలం అంటారు. So generally this is given by this also, that is what? The E cell is given as E naught of cathode minus E naught of anode. This can also be written as E naught reduction potential minus E naught oxidation potential. And if you take any cell, if it has same EMF at all conditions, that means the cell with constant EMF is called as standard cell. అంటే ఒక ఖచ్చితమైన ఎలక్ట్రోమోటివ్ ఫోర్స్, విద్యుత్ చాలక బలము కల విద్యుత్ ఘటాన్ని మనం ఏమంటామంటే ప్రమాణ ఘటం అంటాం. టు క్యాలిక్యులేట్ ఎలక్ట్రోమోటివ్ ఫోర్స్, a scientist called Nernst, generally called as Nernst or Nernst, proposed one equation, that is Nernst equation. So for example, what is the Nernst equation? It gives the relationship between the concentration of ions and electrode potentials. The equation which tells about the concentration of ions and the electrode potential. So for example, a metal ion plus n electrons to form here. Means what here? A metal ion, by absorbing n electrons, by gaining n electrons, is converted to m. So for this, the Nernst equation is given as E m plus n by m. Why? Because m plus n, that means the metal ion with charge positive n is converting to m. Give us, this is given by E naught cell minus 0.0591 by n log m by m plus n concentration. And how does it come? Means actually this is given as E m plus n by m is equals to E naught m plus n by m minus 2.303 by nf log the concentration of M by concentration of M plus N. And here, this N is equal to number of electrons, F is equal to Faraday. So by this one, by simplification, we are getting this value. And here the concentration of metal will be considered as unit, and hence this can also be written as minus 0.05915 N log. Here the concentration of M will be taken as 1 and hence it can be written as like this. For example, an electrochemical cell, we can also write like this. That means A moles of A plus B moles of B react with each other, and we are getting what? C moles of C and D moles of D. So for this, how can we write this next equation? The concentration of C to the power C into concentration of D to the power D divided by the concentration of A to the power A into the concentration of B to the power B. Generally, the concentration of pure solids and liquids is taken as unity or 1. And simply what can we write? This reaction can be written as, that means this E cell becomes 1. Why? Because the concentration of pure solids and liquids has taken, and hence this can be written as and by substitution of this and simplification, this 2.303 divided by 96,500 coulombs, this can be written as what? 0.0591. So from this equation, we can calculate the EMF of a cell by knowing the number of electrons which are transferred in the reaction, and by knowing the equilibrium constant, we are able to calculate that one. This electromotive force can also be considered as free energy, and there is a relation between the electromotive force and Gibbs free energy by this equation, that is delta G naught is equals to minus NF E naught cell. And if we equate the above two reactions, we can get, so the relation between the free energy change and equilibrium constant can be written like this. Delta G naught is equals to minus 2.303 log Kc. So ఈ ప్రాబ్లమ్స్ ఈ ఫార్ములాస్ మీద ఖచ్చితంగా కూడా మనకు ప్రాబ్లమ్స్ వస్తున్నాయి. నెక్స్ట్ కండక్టెన్స్, వాహకత్వం. సో వీఆర్ సెండింగ్ ద ఎలక్ట్రిసిటీ టు ది వైర్స్, డెఫినెట్లీ దే హ్యావ్ సమ్ రెసిస్టివిటీ, విద్యుత్ నిరోధం. సో కండక్టివిటీ, conductivity can be what? This is a reciprocal of resistance. Reciprocal of resistance. So that can be written as G is equals to 1 by R. And the units of resistance or resistivity is called as ohms. And here the conductivity means what? It is reverse reciprocal. So therefore, the units of the conductivity can be called as ohm inverse, can be expressed or mho, and this can be shown like this. So here the units of conductivity will be called, it is ohm inverse or mho. This can be shown as like this also. And what is specific conductivity? Specific this is also called as conductance. What is this? This is the reciprocal of specific resistance. That is, this is denoted by kappa. This is 1 by rho, where this is given by L by R into A, where L by A is called as cell constant, this R is resistance. And from this, we can also write like this, G into L by A. What is L by A? That means the length between the two electrodes and their cross-section area. A is cross-section area. And L by A is called as what? Cell constant. And what are the units of specific conductance? Means ohm inverse, centimeter inverse. And this ohm inverse can also be called as Siemens. So therefore, we can what? We can represent like this. Siemens centimeter inverse, or like this. This is about the conductance, specific conductivity. Now we are going to see about the molar conductivity and equivalent conductivity. What is this? Molar conductivity and equivalent conductivity. What is molar conductivity means? The conductivity of all ions produced when 1 mole of an electrolyte is dissolved in V volume of a solution is known as molar conductivity. The molar vahakatvamu antaru. 1 mole గాఢత గల విద్యుత్ విశ్లేష్యంలో దాని యొక్క ఘన పరిమాణం ఎంత? VmL ఘన పరిమాణం గల 1 మోల్ గాఢత గల విద్యుత్ విశ్లేష్యంలోని అయానులు ఉత్పత్తి చేసేటువంటి వాహకత్వాన్ని, that means the conductivity of all the ions produced when 1 mole of an electrolyte is dissolved in VmL of the solution is known as what? Molar conductivity. And this is given by lambda m. This is equals to 1000 kappa. What is kappa? This is what? Specific conductance, specific conductivity or conductance by m. And what is equivalent conductivity? Very simple. Here the concentration is changed. There 1 molar solution is taken. Here 1 equivalent weight solution is taken. That means the concentration is expressed in terms of equivalent weights in this constant. So this is given by what? Lambda equivalent is equals to 1000. This is called as kappa by n. This is normal. And what are the units of molar conductance? That is Siemens centimeter square mole inverse. And this is what? Siemens centimeter square gram equivalent weights. Gram equivalent weight inverse. And this can also be denoted as ohm inverse, Cm inverse, equivalent. And this is also known as what? Ohm inverse, Cm square, whole inverse. And very important aspect here, what is the role and what is the change in the molar conductivity and equivalent conductivity by the dilution? By dilution, the molar conductivity and equivalent conductivity increases. And specific conductivity decreases. Because by the dilution, the moment of ions increased and hence it increases. And here the number of ions present in one CC will be reduced and hence specific conductance decreases.